Okay, so next topic is measurement of vertical angles, right? So up to last previous lecture, right, we studied about the measurement of horizontal angles, and now we are going to see about the measurement of vertical angles, right? So what is mean by vertical angle, right? So vertical angle is the angle, right? It is the angle a particular object is above the horizontal, right? If it is the horizontal plane, if particular object is above this horizontal plane, suppose I am having object here, so from this point I am going to sight this particular object, right? So this is the line called line of sight. If this line of sight is making the angle with this horizontal plane, okay, that angle is called vertical angle. That angle is called vertical angle. This vertical angle may be the two types. One is angle of elevation and the angle of depression, right? Angle of elevation, and second one is the angle of depression, right? So when it is called elevation means if I am taking this is a horizontal one, if the point is above the horizontal plane, if I am sighting upward, this angle is called angle of elevation, angle of elevation. If the point B is at low lying of this horizontal plane, okay, so this is called angle of depression, angle of depression. Okay, so this is what is mean of vertical angle and what are the different types of angle, vertical angles, angle of elevation and angle of depression. Okay, then coming to the our instrument, that is theodolite, right? We already know to measure the vertical angles by using theodolite we have telescope, okay, which is fitted to the Trunnion axis, right? Here Trunnion axis will be there. And also we have one gradated circle called vertical circle. Gradated circle called vertical circle. Here we have values from 0 to 360. On both sides we have some verniers. Let us say here it is C and D. Two verniers on the both sides. For upper plate, lower plate we have there A and B verniers. No, like that two sides we have verniers. Okay. So those we are taking it as C and D. C and D. Angles also will be 0 to 360. Okay. So here also we will go for face right and face left. Okay. Whatever you did in the case of what is called horizontal angles, right? So now before going for the measurement of vertical angle, okay, we know that theodolite is having two types of bubble tube. One is at altitude bubble, another one is at bottom, right? If this is the instrument, in the case of horizontal angle, we may use the bubble which is at the above, just above the all 3 foot screws. Okay, so now for the vertical angle measurement, here in the T frame, okay, we have one part called T frame. Here we have a bubble called altitude bubble, right? What is that? Altitude bubble tube or altitude leveling tube. We are going to use this altitude bubble tube or altitude or level, right? So with the help of this we are going to make the instrument to be a level. Okay, first of all we know we are going for the leveling the instrument with the altitude level, right? This the procedure will be same, right? The procedure will be same as like we used in the case of horizontal level, what is called what vertical leveling, no? So normally 3 foot screws will be there. First of all we are going to keep parallel to 2 foot screws, then we need to change the bubble to the vertically, right? So in the both direction we are going to do the leveling. Okay, so but we are change the bubble to the altitude bubble which is at the top. With the help of that bubble tube we are going to make it level, right? So once the leveling is finished, now what you have to do, we need to rotate this telescope. We need to rotate the telescope. Suppose if that is at some particular height, if I am putting instrument here, right, if my instrument is here, right, so this is the tripod I kept here. I want to find the vertical angle from the from here to point A to B. Okay, first I want to see I will turn this telescope towards the B and I am going to sight. Okay, so first of all I know this horizontal plane. Okay, so when you will get horizontal plane, whenever you did this leveling, okay, that leveling is level plane, it is going to give the level plane. It is the reference line where we have 0 angle. Okay, and also you need to set this thing 0 to 0. Okay, so once it is kept 0 to 0, then you sight it towards the point B. Okay, you need to tilt your what we can say telescope towards the B. Okay, and now actually to move this telescope, right, we have the screw there. Okay, clamp screw will be there, vertical circle clamp screw will be there. By rotating that, we are going to tilt the telescope towards the B. If you need very small movement of telescope, you are going to use the tangent screw. Okay, we know already we have two types of screws. One is clamp screw, that is vertical clamp screw, and we have another for small movements we have tangent screw. Okay, we are well known about these two screws. Whenever you are going for major rotation, now you can use the clamp screw. If it is very small movement, now you are going for the tangent screw. So by using these two type of screws, we are going to sight the point B. Then you are going to tighten the clamp screw, right? So then you need to go here to the vertical circle where we can see the angles on both sides of verniers on the both sides. Okay, now the entry of reading will be the same as like horizontal one, but here instead of A and B verniers, we are going to take C and D, right? So whenever you are seeing at a particular point, now the instrument is at P, and I am going to sight point A. Okay, so now the instrument is at P and I am going to sight point A. Point A is having all values 0, 0, 0, 0, 0. Okay, so finally vertical value also 0. Suppose if I am searching sighting towards the B where I got 30 degrees, okay, 20 minutes, 10 seconds. Okay, so and also here I got 20, 10. Okay, the values won't get same, but there will be some difference. Okay, so the mean will be 30, 20, 10, and the vertical angle is 20, 30, 20, 10, right? 30 degrees, 20 minutes, 10 seconds. Okay, so like that we need to enter the data, right? So this is the observation for face left. Okay, that means your vertical circle is going to be at your right side. Now turn the instrument, bring the vertical circle to your right side, that is called face right observation, where also we are going to sight same point A and B. You need to do again vernier values in the C and D and mean value, vertical angle and average. Finally you are going to keep the average angle, that is 30, 20, 10 in front of degrees, minutes and seconds. Okay, so like this vertical angles to be measured with help of the theodolite. Okay, next, the next topic is trigonometrical leveling. Okay, so the next topic after theodolite in the third unit, we have next topic called trigonometrical leveling, right? So what is mean by trigonometrical leveling, right? So in the name itself, the first term is telling that it is a trigonometry. Okay, trigonometry will deals with the angles. We know that trigonometry will deals with the angles. We studied in the intermediate as well as in the school days. Trigonometry completely deals with the angles. And the next term is leveling, right? You are going to do the leveling. After doing the leveling, what value you are going to get? You are going to get the elevations. Leveling will be done to find out the elevation. That means what is the location of a point which is locating above or below the horizontal or earth surface. That distance, the vertical distance, is called as the elevation. Okay. Now the complete term is coming like that. We are going to determine the elevation of a particular point or object, okay, with help of vertical angles. With help of vertical angles. Since the elevations are in the vertical direction, no? So whatever angle you are going to take, it is called vertical angle, right? So for the trigonometrical leveling, we are going to use the instrument same, that is Theodolite. The instrument used same, Theodolite, right? So that Theodolite will be, if this is a ground surface, right? We are going to set up the instrument here. We are going to set up the instrument here, right? So this is the telescope, and I want to know the level, right? The level difference from point A here and the point B is here. I want to know this distance. I want to know this level. Okay. So now the level difference, okay, to find out these values. Suppose if I am taking it as yes, if I am taking it as a yes, I am going to cite this A. Okay, it is in what is called in horizontal level. Okay, so and I am tilted towards the telescope towards B, and I found out the angle theta. Now here, what is my thing? The value of this elevation is going to determined by using this angle theta and the horizontal distance between from instrument to the station, right? So this horizontal distance can be can be measured with help of tape or chain. Okay, for exact reading we are going to measure with help of the tape. Suppose in the surveying basics we have two types of surveying. One is plane surveying, another one is the geodetic surveying. Okay, so what are those? We have plane surveying, next geodetic surveying. Okay, plane and geodetic surveying. What is meant by plane surveying? Here we are going to take the horizontal plane surface, but in the case of geodetic we are going to consider the earth surface as a curve. Okay, here the earth surface is treated as the horizontal plane, right? So now in the plane surveying we can measure with help of the tape. Since it is a straight line, we will calculate the d value. And if you are going for the geodetic surveying, you are unable to measure that. You need to calculate you need to compute the value, you need to compute the distance. So anyhow, either it is a plane surveying or any geodetic surveying, you are going to compute or you are going to measure the horizontal distance, and you are going to measure the angles, vertical angles. With help of these two values, we are going to determine the elevation of a object. This type of leveling is called trigonometric leveling. Why it is called trigonometric leveling? Trigonometry refers to the angles, but this trigonometrical things we are applying for the determination of levels, that is called elevations. Okay, so the elevation is normally we said it is in the vertical plane, right? So that's why the angles whatever we are going to take, those are the vertical angles. So the definition is going like that. Okay, like this. The process of determining the differences of elevations. Ikkadi nunchi ikkadiki enta difference undi, ee value enta, yes. Okay, so we are going to know the difference of elevations of station from the observed vertical angles, and known distances, Okay, either it may be horizontal or geodetic distance. If it is horizontal distance, we are going to measure with the help of the tape or any other instrument. But if it is a geodetic distance, we are going to compute the distance, right? So, but we have to what is called, first we have to set whether it is a plane surveying or geodetic surveying. First you need to fix this, then you are going for the angles, and then we are going for the distances. By knowing distance and angle, we are going to know the vertical elevation, right? So that is called trigonometrical leveling. Okay, so in this trigonometrical leveling we have three cases. Okay, so to find out these elevations of a station, the difference in the elevation of station, we have three cases. Okay, under the heading called heights and distances. Okay, heights and distances. Heights and distances. Okay, now we will see what are those three cases. Okay, so the first case is case 1, right? Case 1. Case 1 is refers to the base of the object is accessible, right? Base of the object is accessible. That means this is the base. Okay, this is the object. This base is going to accessible. That is from the station. Okay, this is called from this instrument station, right? So you can come to this point and you can go, right? So you can easily accessible to this particular station. Okay, so that is object, base of the object is accessible. And case 2 is having, case 2 and case 3 are base of the object is inaccessible. We are not going to go there. That means in between the river or pond or ocean, anything is there, we are not going to access to this particular base from the instrument. That type of case is called base of the object is inaccessible. So the first thing is base of the object is inaccessible. Base of the object is inaccessible. So here instrument stations in the other thing is called instrument station is in the same plane as the elevated object. Okay, that means this is the plane of both instrument as well as the object is located. This is the same plane. Okay, are you understanding? This is the same plane where both instrument and as well as the object is there, but we are not going to access. That means in between we have a river. We are not going to see this. Suppose this point may be on the hillside, in the forest also, where we can't go and see the base point. Okay, the thing is now the base is inaccessible. Now the thing what he told now, instrument station is in the same plane as the elevation object. This is the instrument station. This instrument station is the same plane of the base of the object. Okay, object అయితే ఏ plane లో ఉంది అదే plane లో మనకి instrument అనేది ఉంది. Then case 3. Okay, now we can easily say case 3 will tell that base of the object is inaccessible. Base of the object is inaccessible, but the instrument station is not in the same plane as the elevation of the object. Okay, ఇక్కడ same plane లో ఉన్నాయి, ఇప్పుడు different planes ఉంటాయి. అంటే ఎలా ఉంటుంది? If this here is the instrument, right? If this is the thing, okay, the object will be at this point. Okay, you see base is here, the base is here. Okay, it is not in the same plane. Okay, so it is at the different planes. Okay, you can see here, this is at the different plane. It is somewhat height, it is having some elevation. Okay, so now the instrument station is not in same vertical plane as the elevated object, Okay, so like this we have three cases. In our syllabus also we are having trigonometric leveling. What is mean by trigonometric leveling? And the heights and distance measurement when base is accessible and base is inaccessible. Base is accessible, we have only one case, and base is inaccessible, we are having the two cases where instrument and object are at the same plane, and the third case, it is there, instrument station is not in the same plane as the elevated object. Okay, now we will see one by one with from the case 1. Okay, now let us see the case 1. Okay, what is case number 1? Where the base of the object is accessible. Okay, if the base of the object is accessible, we can measure the horizontal distance from the station to the what is called instrument station to the particular object. Okay, so we are going to measure the horizontal distance between the instrument and as well as the object. Okay, suppose if I am taking a plane, okay, if I took the plane where I set up the instrument here, Theodolite, I set up the instrument, okay, and by keeping my level, okay, leveling staff over a benchmark, I find out the height of instrument. That height of instrument is h dash, small h dash, right? So then whatever reading I am taking over the benchmark, right, that is S. Okay, finally I got a value of h dash. Okay, now this instrument where I kept, that is point P. Okay, now I am going to take a object. Okay, I am going to take a object. Okay, it is at Q, the object top point is at Q. Okay, so now if I am extending this plane, okay, height of instrument, that level plane to the, here I got a point called Q dash. And the corresponding ground point, what I am going to take it as Q1. Right? If I am sighting from P to Q, I got the angle of alpha. Okay, the center of the instrument is at a point A. Okay, and the level difference from this horizontal plane to this vertical object, that is I am taking as h. And the horizontal distance between object and instrument is taking as the capital D. Okay, so now we will see one by one. The first thing is P. P is the instrument station. Okay, next Q is the what is Q here? That is point to be observed. Okay, point to be observed. Okay, next A is the center of the instrument. Okay, next A is the center of the instrument. Then q dash. Q dash is the projection of q, right? Projection of q on horizontal plane through A, right? Through A. Okay, so if you draw the horizontal plane through A, the projection of q on this plane is q dash, right? Next, D, capital D. So capital D is the distance from A to q dash, right? A to q dash. This is the horizontal distance between P and Q, right? It is the horizontal distance between P and Q. Okay. Next, H dash, right? H dash. What is meant by H dash? H dash is the height of instrument at a particular point P, right? Height of instrument at point P. Right? That is the height of instrument. Next, what is remaining? And we have S, right? S is the staff reading at benchmark, right? S is the staff reading at benchmark. Staff reading at benchmark with the line of sight horizontal. Okay. And last we have H, right? What is H? H is the distance between Q dash. Okay. H is the distance between Q and Q dash. Okay. So and then alpha. What is alpha? This is angle of elevation from A to Q. This is the angle of elevation from A to Q. Okay. So these are the terms we are going to locate here. Okay. Starting from station point P and Q. Instrument is at A. Okay. This is the height of instrument. This is the reading on the leveling staff over the benchmark, and alpha is the angle of elevation, and D is the distance from station to the object, right? So object is at Q, and the projection of Q to the horizontal plane which is going past through the A is Q dash. The distance between two Q and Q dash is the H. Okay. So these are the things we need to know. Okay. Now how to know the H value here? Okay. So we want to determine what is our basic trigonometrical principle with help of the angle which is observed from the station and the distance between from station to the object. With help of these two values, we are going to know the elevation of a particular object. That is the basic principle of trigonometrical leveling. Okay. Now what you have to do? Now from the triangle Q dash A Q. Okay. So from the triangle A Q dash A Q dash. Okay. What is H? H here you can see here tan alpha is equals to Q dash divided by A Q dash. Q dash divided by A Q dash. What is Q dash? Q dash is small h, A Q dash is D. A Q dash is the D. So from here H value will equals to D tan alpha. Okay, H value is equals to D tan alpha. So here I am writing H is equals to D tan alpha. Okay. So now RL of reduced level, right? So that is RL, right? RL of Q is equals to RL of the instrument axis, RL of the instrument axis plus H. Is it right? Okay, so what is the RL of this point? RL of the instrument is this. Okay, so above this we have a small height of H, right? Height of H. So this will be equals to RL of instrument axis, not instrument, it is instrument axis. So H is equals to d tan alpha, right? Now what you have to know, we need to know the RL of instrument axis. Okay, so now RL of Q will be equals to this. RL of Q will be equals to RL of what is it? Q is at instrument is at point P. Okay, RL of P. This is the RL of P. P plus H. If you want to get this elevation of this particular plane, you need to know the angle of what is called RL of P plus H dash. So RL of P plus H dash plus d tan alpha. H dash plus d tan alpha. Okay, so now if the staff reading is kept over the benchmark, okay, so that value is yes. If you know the S value, right, the RL of benchmark is got changed, right? So RL of Q value, right? RL of Q will be given when you know this reading, right? This reading. So then what will become? RL of BM, RL of benchmark plus capital S plus d tan alpha, right? So when this is when benchmark and S values are known, benchmark and S values are known, this is the method. Okay, so if this is the used when RL of P is known, RL of point P is known. Okay, like this we are going to know the reduced level of point object, there is Q. Okay, so when the base of the object is accessible, right, we are going to measure the horizontal distance. Now if you want to know the RL of Q, what you have to do? Okay, you need to use this formula or this formula. If you are using this formula, RL of P easily can be measured, this value can be measured easily, right? So d tan alpha, out of d tan alpha, d will come from the horizontal distance with help of the tape, and alpha value will calculated from the, sorry, it is measured with help of the theodolite, that is with help of the instrument. And same thing will be proceed even benchmark value we know, then S value, staff intercept on the leveling staff we know, d tan alpha again we know. So with help of these all values we are going to find out the RL of Q. Okay, so this is the case when the base of the object is accessible, right?